Hey everyone, this is 2012 question 1, specifically in regards to Riemann Sum. Here we go, part A. So here we need to estimate W prime of 12, which is an instantaneous rate of change. So if we want to estimate it, we'll use the next best thing, which is the average rate of change. And the two coordinates closest to 12 would be 9 and 15 in this case. So it's pretty much straightforward in regards to the scoring guideline. I would probably just write it as 67.9 minus 61.8 all over 15 minus 9. No need to simplify it. But in terms of the interpretation, it does help you out. If you take a look at the scoring guidelines, this did come out positive, greater than 0, okay? So this helps out, especially when you want to interpret the meaning of your answer. So it goes back to graph analysis. When your derivative comes out positive, you know that W is increasing. So W in this case, if you read the problem, it represents the temperature of the water in a tub. So since W prime came out positive, we know that W, the water temperature, will be increasing at a rate of, and then you can do the whole equals equal, or in this case 1.017. But most importantly, the units are here, degrees Fahrenheit per minute at that time. Okay, so that was our approximation. Make sure that you guys have the degrees Fahrenheit per minute, and specifically at t equals 12 minutes there, okay? Part B. Use the data in the table to evaluate the integral of W prime. So right there, again, it popped up again in 2011. It reappeared here. You're taking the integral of a derivative, which you should know that's FTC, I can't remember, 1 or 2, but when you take the integral of a derivative or vice versa, you get the original function. So here, notice how we just get the function and we plug in our upper minus our lower. Okay? Now, W of 20, according to the table, W of 20 is actually 71 here, okay? And W of 0 is actually 55. Now, we're going to have those two values here. We subtract it out, and we're actually going to get 16. But the AP Reader actually wants you to know what 16 really means. So a way to figure this one out is, first, think about what 71 and 55 means. Okay? According to our table, 55 and 71 is in reference to the degrees Fahrenheit. So this is the temperature, in this case, of the water in degrees Fahrenheit. So if you took the temperature of the water at the 20-minute mark, and then you subtract it with the temperature of the water at the 0-minute mark, you get 16. So this means that the water has increased since 16 is positive. Now, if 16 was negative, you would say the water has decreased. The scoring guidelines use the word warmed. It really doesn't matter, but some indication that the water is increasing in temperature. Notice how they didn't just put 16, but they put 16 degrees Fahrenheit. Notice how in the problem it says, use correct units. So a lot of people tend to just forget that part there, okay? The water has increased by 16 degrees Fahrenheit over the interval or over the course of 20 minutes. Or you could use what they did there over the interval from t equals 0 to t equals 20 minutes, okay? So far in parts A and B, there is your minimum 4 points, okay? Part C. So the average temperature of the water in the tub is 1 over 20 integral of W. So notice how the 1 over 20 indicates the average there, okay? They want you to use a left Riemann sum going from 0 all the way to 20. So in this case, we're actually going to use the entire table. But again, I want to note that we want to indicate an average, okay? And we'll follow up with that second question in a second. So if you look at the scoring guidelines, they tend to write a little bit more than necessary. So I encourage you guys to not write that part, because sometimes, well, people write it incorrectly and you could actually lose points there. So make sure that your math is accurate. Less is definitely more. So the 1/20 is your average. Just keep that in mind. Here they wanted a, I believe, left Riemann sum. They wrote 4 times W of 0. You could do that. You're more than welcome to do so, but I think it's just easier to just use your values. So for a left Riemann sum, you have the base, which is the horizontal distance here, which is 4, times the left endpoint, which in this case would be 55, okay? You do the same pattern here. So I encourage, and I think most of you guys would write it like this. The next one would have a horizontal distance of 5 times the left y value, and so forth, okay? Again, this is a calculator question, but you could still leave it. I would leave it just like this, okay? That right there itself would give you the 1 point and the second point. But if you were to continue, you do have to get 60.79 there, okay? The follow-up to that question is they ask you, does the approximation overestimate or underestimate the average temperature? So remember, if you want to know if it's an over or approximation, there needs to be 3 components. I'll highlight it here. There needs to be a left Riemann sum. Now, in order to figure out if a left Riemann sum is an underestimate or an overestimate is based on the direction of the graph. So if you read it carefully enough, they will provide you some indication that W in this case will be either increasing or decreasing. If you go through the text here, they tell you right at that very first sentence. And they tell you that for a reason, because eventually they want you to kind of answer this over-under question here, okay? Now, oftentimes people don't remember what the estimate is, so I tend to just draw it out. I'm going to draw an increasing function, any type of increasing function, and I'm going to draw left Riemann sums. So this is where the left endpoint will determine the height. Because honestly, there's a lot of rules and I can't seem to remember what's what. But if you notice that when we're drawing left Riemann sums, all of those rectangles are underneath the curve, so we know it's going to be an under approximation. So, advice here, just draw it out so that you know. But in order to get this third point for the underestimate, you need to have 3 components. AP readers made it very clear that in order to get this point, you have to have all 3 stated. Underestimate, the type of Riemann sum, and the direction of the graph. So keep that in mind, okay? Last part here, part D, the function W from 20 to 25 in this case models the water temperature given by this first derivative, okay? So we know it's a rate. Based on the model, what is the temperature of the water? So, same thing here. If you're given a rate and you just want the temperature, there has to be some integration involved. We're interested in the temperature of the water at 25. So we want to know how much accumulation has involved from 20 to 25 here. So we know we have to integrate from 20 to 25. Okay, that'll give us the accumulation. But we do have to consider how much we started out with. So in this case, the start point is 20, and they actually tell us what the temperature is at the 20-minute mark. And how do we get that? It's right there at that table, right there on the upper right. So if you ever want to know a certain temperature or the amount of oil in the tank or the amount of people in the park, you always have to consider how much you start off with. In this case, our start off value is at t equals 20. So we do have to consider the temperature of the water at that moment. Okay? This is a simple plug and chug. You get your answer there. If you take a look at the scoring guidelines, they give you 1 point for the integral. And an extra point if you actually consider the initial value there. That'll give you your final answer, okay? And that's it.